Hi friends, good morning to everyone. Welcome to my channel Belagali's class. Friends, we have started with vectors. We have done so many things in vectors. Presently doing with scalar or dot product of two vectors. Scalar or dot product of two vectors. Done the related properties of dot product and examples connected with definition and properties of dot product examples we have done. Yes, my friends, as a reminder, just once again, I will go quick. It is a dot or scalar product. It is a definition. A dot B equal to magnitude of A into magnitude of B into cos theta. This theta is the angle between the vectors A and B. Theta is the angle between the vectors A and B. It is the definition of A dot B or scalar product. These are the properties. B dot A is A dot B. Commutative property is true in case of dot product. It is a dot product of vector with itself is square of its magnitude of A the whole square. Then third is A dot B 0. If the dot product is 0, then the vectors are perpendicular. If the vectors are perpendicular, then their dot product is 0. This is the fourth one. If the vector A equal to A1i plus A2j plus A3k, vector B equal to B1i plus B2j plus B3k, then A dot B equal to A1 B1 plus A2 B2 plus A3 B3. This formula, it is a formula to work out the dot product. These one, I dot I, J dot J, K dot K is 1, and if they are different, I dot J is 0. J dot K 0, K dot I is 0. Unit vector means its magnitude is 1. If the magnitude of any vector is 1, it is a unit vector. If the magnitude is 0, then it is a 0 vector. Yes, my friends, it is vector in the form of a point in the plane x, y, z. Then OP is the position vector of the point P is given as xi plus yj plus zk, and its magnitude is given as root x square plus y square plus z square. This, my friends, just in brief, quick, we have seen, reminded the things which we needed in future while doing the examples, my friends. Yes, the same scalar product is continued. The next part of it is geometrical meaning of scalar or dot product. Yes, my friends. Geometrically, what it represents, A dot B represents, you have to see in this expression. Let OA, vector OA equal to A and OB equal to B are the given vectors, and theta is the angle between them. Angle between them means angle between the vectors OA and OB. These are co-initial vectors or vectors A and B. See, my friends, this is the figure. Let OA, vector OA equal to A, vector OB equal to B are the given vectors. Theta is the angle between the vectors A and B. The direction is from A to B, my friends. Theta. This is the construction part. Draw BM perpendicular to OA. Then you are observing this OM, my friends. This OM, this part OM. This OM is called or defined as what? Projection of vector OB on vector OA. It is a definition of projection. This is one line, this is another line. If you draw a perpendicular from the above line to the down, then this whatever you have along OA, vector OA, this piece OM, that OM is defined or called as projection of OB, vector OB above, vector OB on down is what? Vector OA or what is OB, my friends? B. What is OA? OA is A. Therefore, this OM equal to this OM equal to projection of vector B on A. Projection of vector B on A. This is by definition, my friends, OM. Now it is a right-angled triangle, right-angled at M. In a right-angled triangle, we can define the trigonometric ratios. We want OM. This OM is nothing but what? Adjacent side of theta. That adjacent side defines what? Cos. Therefore, from the triangle OBM cos theta equal to, from the triangle OBM cos theta equal to adjacent side OM upon hypotenuse opposite to 90, OB. I have written the same here. From the triangle OBM, we have cos theta equal to adjacent side OM upon OB. What is this OB? OB is a line segment. This line segment can be converted into magnitude of directed line segment means factor. OB is nothing but magnitude of factor OB. This magnitude means what? Length. But what is this OB? Is factor B. Therefore, you have cos theta equal to. Therefore, this is cos theta equal to OM upon B. Bring this side. Factor B into cos theta equal to OM. Factor B into cos theta is OM. Yes, my friends. You name this as 1. This is 1. We wanted what? The geometrical meaning of A dot B. Now, by definition, A dot B is magnitude of A into magnitude of B into cos theta. The definition is reminded. But what is magnitude of B into cos theta? This magnitude of B into cos theta is OM. Why? Because by 1. This is 1, my friends. Because by 1. Now you solve for OM. This OM equal to A dot B upon magnitude of A. This OM is A dot B upon magnitude of A. That is OM equal to A dot B upon magnitude of A. But what is OM? But OM is a projection of factor B on A. Write the same thing. That is projection. OM is projection of factor B on A equal to what is RHS? A dot B upon magnitude of A. A dot B upon magnitude of A. Yes, my friends. This is the geometrical meaning or expression for A dot B. Then what is it? It is a projection of B on A equal to A dot B upon magnitude of A. Or we can give A dot B equal to magnitude of A into projection of B on A, or A dot B here. Similarly, this is B on A. A dot B upon magnitude of A. What is the denominator? On A, this factor, my friends. On A comes down. A dot B upon on A, magnitude of A. If you interchange them, projection of A on B. A dot B upon, what is the denominator? On B. So it is magnitude of factor B. Yes, my friends. This is the theory part, the geometrical meaning of what, my friends? A dot B. A dot B is either magnitude of A into projection of A on B, or magnitude of B into projection of A on B. You can take any one. Yes, my friends. I give 2 minutes. Please copy it. Copy. Quick. Quick. Yes, friends, you know, I will repeat the formula. Projection of B on A is A dot B upon magnitude of A, and projection of A on B is A dot B upon magnitude of B. Numerator is same, A dot B, but what is different is the denominator. How to remember it? On A, projection of one factor on another factor, denominator is on another factor, this is down. On B, that will be in the denominator. Yes, my friends. Now, I will do some 2-3 verifications based on this. They are also important under 2-mark questions. 2-mark questions. Yes. Yes, friends. I have written the example there. Find the projection of factor I plus 3j plus 7k on another factor 7i minus j plus 8k. Then you denote this equal to factor A, this equal to factor B. Right, my friends. This is the solution of that example. Yes. Let factor A equal to, that is the first factor I plus 3j plus 7k, and the factor B equal to 7i minus j plus 8k. Tell my friends, you wanted projection. First to find it is projection of, find A dot B. A dot B is what? Use that. A1 B1 plus A2 B2 plus A3 B3. This, my friends, it is a practical formula to find A dot B. A1 B1 plus A2 B2 plus A3 B3. A1 B1, 1 into 7 plus 3 into minus 1 plus 7 into 8, 56. Yes, 7 minus 3 is 4. 4 plus 56 is 60. A dot B is 60. Then you wanted what? Magnitude of A on B, magnitude of B. Which is square root of 7 square. This formula, my friends. Xi plus yj plus zk. What is the magnitude? Square root x square plus y square plus z square. What about x, y, z? They are the coefficients of unit factors ijk. Unit factors ijk. Here, my friends, magnitude of B 49 plus minus 1 the whole square plus 8 square 64. Yes, friend, this is equal to, it is square root, it is 50 plus 60, 110 plus 4, 114. Yes, first we wanted projection of first factor, write only this much, my friend. Projection of A on B which is A dot B upon magnitude of A. What is this, my friend? A dot B is 60 upon root 114. 114. Tell what is next? Note, my friend, I do that also. Note. They may go for what? Projection of B on A. Projection of vector B on A. It is also what? A dot B upon magnitude of A, my friend. Second vector, magnitude of A equal to A dot B is 60 down. Square root magnitude of A 1 square plus 3 square plus 7 square, which is 60 upon 50 plus 9, root 59. Root 59. Yes, my friend. Even sometimes they go for what? The projection of what? Ratio. Projection ratio of what? Projection of A on B upon projection of B on A. This upon this. What cancels, my friends? A dot B common cancels. If it is A on B, this will be in the denominator. Reciprocal. This will be on the numerator. On the numerator. Remember, my friend. Sometimes they may ask. Okay. Next question. Next question. Next question is this, my friends. If example 2, if A 2, 3, 4, these are the coordinates of the point A, 2, 3, 4. B, second point, its coordinates are 5, 4, minus 1, and one more point is C with coordinates 3, 6, 2. Yes, my friend. This is the third point. And D. The coordinates are 1, 2, 0 are the given points. Find the projection. Find the projection of vector AB on vector CD. Vector AB on vector CD. My friends, first you have to find the vector AB, vector CD. For that, you write, taking O as the origin of reference, position vector of the point A, OA, 2i plus 3j plus 4k. You have to make use of this, my friends. Pxyz. Pxyz is a point, then vector, position vector of the point P is what? These coordinates are multiplied by what? Ijk, unit vectors, and add them. Yes, my friends. Let O be the origin of reference. O be the origin of reference. Origin of reference. Then, yes, position vector of the point A, OA, is 2i. plus 3j plus 4k. Second vector, position vector of the point B, OB, multiply 5i plus 4j minus k. OC, third vector, this is 3i plus 6j plus 2k. Position vector of the point C, fourth one. Position vector of the point D is this, my friend. This is 1 into I plus 2 into j plus 0 into k. Yes, my friends, I have written the position vectors of the points A, B, C, D, A, B, C, D. Then you wanted what? AB. You know what is AB? That AB is now factor AB. Factor AB, you know the formula. Position vector of the point B, second point, minus position vector of the point A. OB minus OA. This is OB, this is OA. OB minus OA, 5 minus 2, 4 minus 3, minus k minus 4k, minus 5k. Next wanted another factor is CD. Another factor is CD. What is this? Position vector of the second point minus position vector of the first point. OD minus OC. Right. This is OD, this is OC. You wanted OD minus OC. I minus 3i minus 2i plus 2j minus 6j remaining. 0 minus 2k. Minus 2k. Yes, my friends, what you wanted? Projection of AB. Projection of AB on CD. Next wanted projection of vector AB on CD. Vector CD is equal to vector AB dot CD, vector CD. Denominator is the second vector. Magnitude of vector CD equal to. Yes, my friend. This is AB, this is CD. 3 into minus 2. 3 into minus 2 plus 1. This is 1 into minus 4. 1 into minus 4 plus coefficients of k. Minus 5 into minus 2. This is minus 5 into minus 2. Denominator is magnitude of CD. Magnitude of CD. CD is this. Minus 2 the whole square plus minus 4 the whole square plus again minus 2 the whole square. Yes, my friends, simplify. This is minus 6 minus 4 plus 10. Denominator is square root 4 plus 16 plus 4. So it is 10 minus 10 means 0 upon root 24. When the numerator is 0 means what is this, my friend? 0. Therefore, projection of AB, vector AB on CD equal to 0 implies, tell my friend, that projection OM is 0. Yes, my friend. This is vector AB. This is vector AB This is factor CD. CD. From A, you are drawing what? Perpendicular AL. You are drawing perpendicular VM. Then this LM is the projection of AB on CD. LM is, this is factor EB. This is factor CD. Perpendiculars. This line, my friends, LM. This LM is projection of AB on CD. If the projection is 0, in that case what? Factors AB and CD are collinear, otherwise they coincide. Is correct. So factors AB and CD coincides. They are coincide factors or collinear factors. Collinear factors. Yes, my friends. This is another example. Yes, my friends. Hope understood. The vectors are given in the points in the form of points. Write the position vectors. After finding the position vectors, writing the position vectors, find the vectors AB and CD. AB is OB minus OA. Ready? OB minus OA. CD, OD minus OC. This minus this. Then projection of vector AB on CD is AB dot CD. This, my friend. AB dot CD upon magnitude of CD. This is 10 minus 10. When the numerator is 0, projection is 0. Projection is 0 means what? This factor coincides with factor CD. Both are collinear factors, my friends. Yes. Next question is. Yes. Let vector A equal third example 2i minus 2j plus k. Vector B equal to I plus 2j minus 2k, and vector C equal to 2i minus j plus 4k. Then find the projection of vector B plus C on vector A. Just drama, my friends, not direct. Before that, you must find B plus C. Right. Now, vector B plus C, addition 2i plus I, add them, minus plus 0j, plus minus is minus k. This is B plus C. Okay. Denote this as factor X. Then you wanted projection of B plus C equal to vector X on vector A equal to, this is X dot A, down A is, on A is the magnitude of A. Yes, friend, what is this? B plus C is this, Vector A is this, even if I want to write here. Vector A is 2i minus 2j plus k. Yes. Dot product x dot A 3 into 2 6, 0 into minus 2, minus 1 into plus 1 is minus 1. Denominator magnitude of A this 4 plus 4 plus 1, and it is 5 upon root 9, 4 plus 4 plus 1, which is 5 by 3 is projection of B plus C on A. Projection of B plus C on A. Anything mistake we have done? B plus C to Y plus I, 3i minus J plus 2J is J plus 4K minus 2K plus 4K minus 2K is plus 2K. Yes, my friend, some mistakes was there. I thought this. Yes. A is what? 2i minus 2j plus k. Projection of B plus C, we have taken a single vector x on A is equal to x dot A upon magnitude of A, x dot 3 into 2, 6, 1 into minus 2, 1 into minus 2. This is plus 2 into 1 is plus 2. Denominator, magnitude of A is correct. 4 plus 4 plus 1. What is this? Plus 2 cancelled with minus 2. This is, my friend, 6 upon root 9. Root 9 is 3, my friend. It is root. This is 6 upon root 3 is root 9 is 3, which is 2. This is the projection of B plus C on A. Yes, friends. Yes. I do one more. Yes. Yes, my friend. Next example. This is example number 4. Example number 4. Let A equal to vector A equal to 2i plus j minus 3k. Vector B equal to 3i plus 3j minus k. Then find projection ratio of projection of A on B to projection of B on A. Yes, my friends. What you wanted? You wanted the projection of A on B ratio. Projection of B on A. Now what is this, my friend? It is A dot B upon magnitude of B. This upon A dot B upon, this is A, magnitude of A. I simplify this. It is A dot B upon magnitude of B reciprocal magnitude of A upon magnitude A dot B. Yes, my friend, this gives magnitude of A upon magnitude of B. Even sometimes they ask in CT this formula itself. Projection of A on B, the ratio is, if it is A on B upon B on A, always numerator becomes denominator, denominator becomes numerator. Yes, my friend. This is the square root of magnitude of A to the whole square plus 1 square plus minus 3 the whole square. It is square root of B, my friend, B. It is what? 9 3 square plus 3 square plus minus 1 whole square. It is 10 root 14. What is this? 10 root 19. Or you may, using the properties of surds, you can write it is 14 upon 19 is the answer. 14 upon 19 is the answer. Yes, my friend. Just one sample if you wanted. If you wanted one sample, you do this. DIY. Find the projection of vector I minus j on vector I plus j. Yes, my friends, do this. This is about the geometrical meaning that is done, and some 3-4 examples, varieties I have done, my friends. Then after the completion of the scalar or dot product, next comes, my friend, vector or cross product. Yes, copy it. Yes, my friends, next part is vector, or there it is a dot, here it is cross product of two vectors. Vector or cross product of two vectors. Yes, my friends. Definition. The vector or cross product, vector or cross product of two vectors A and B is denoted by A cross B, my friends, denoted by A cross B, and is defined as, yes friends, as A cross B equal to magnitude of A into magnitude of B into sine of the angle between the vectors A and B into, this is extra my friends, eta cap, where theta is the angle between the vectors A and B, and eta cap, this is very important my friends, eta cap, it is not n, and this is n, and this is just stylish, eta cap be the unit factor perpendicular to both factors, A and B, This, my friends, if this is vector B, this is vector A, O, this is vector A, my friend, and this is vector B. This is the angle between them, this is theta. Then this is, my friend, unit factor. This is eta cap. This is eta cap. It is a unit factor in the direction perpendicular to both vectors A and B. It is in the direction perpendicular to both vectors A and B. My friends, this is eta cap. Eta cap is a unit factor, means what? Magnitude of eta cap. It is a unit factor. Magnitude of eta cap is 1. Why it is a unit factor? Then, what about its direction? It is in the direction perpendicular to both vectors A and B, which is same as, it is in the direction perpendicular to the plane containing the vectors A and B. Eta cap is a unit factor perpendicular to both vectors A and B, or it is perpendicular to the plane containing the vectors A and B. As it is a unit factor, its magnitude is 1. Yes, my friends. I will explain once again. Vector or cross. This is cross. My friends, this is dot here. This is dot. Dot is a scalar quantity. See, RHS is no vector, it is a scalar quantity. It is magnitude of A into magnitude of B into cos of the angle between vectors A and B, cos theta. But in case of what? Cross. My friend, that is dot, and this is cross, this definition. This is cross. Yes. The vector or cross product of two vectors A and B, it is a symbolic way of writing. A cross B, their dot. A cross B, and is defined as A cross B equal to same magnitude of the first into magnitude of the second into, there it is cos, but here it is sine of the angle between A and B into eta cap. Eta cap is a unit vector. Look your observation in RHS, scalar quantity, scalar quantity, scalar quantity. But it is a unit vector, it is a vector quantity. Because of this eta cap, RHS is a vector quantity. As RHS is a vector quantity, you are saying what? A cross B is a vector quantity, whereas dot product is a scalar quantity. Yes, my friend. What is theta? Angle between the vectors A and B. This is the direction, my friends. Theta is from A to B. This A to B. Yes. Yes. Eta cap. This is a unit vector whose magnitude is 1. What is the direction? Perpendicular to both vectors A and B, or perpendicular to the plane containing the vectors A and B. This is the definition of what, my friends? It is definition of cross product. Cross product. Cross product. Yes, my friends. Then we have to do the properties of what? Cross product. Properties. This is properties. Properties of cross or vector product. Vector product. These are the properties of this. What is the first property? This is because of this RHS eta cap. A cross B is a vector quantity. A cross B, first property. A cross B is a vector quantity. Whereas but dot product A dot B dot product is a scalar quantity. Scalar quantity. This is first property. Second one. We have to discuss about its what, my friend? Commutative property. Yes. Cross product or vector product. Vector product is non-commutative. It is not commutative. Non-commutative. That is B cross A is not equal to A cross B, but whereas in case of what? Dot. B dot A is A dot B, but in case of what? Cross. It is not A cross B. Yes, my friend. Right. First, by definition. By definition, A cross B is magnitude of A into magnitude of B into sine of the angle between A and B. Theta is between A and B into eta cap. This is theta. I will show it by a figure itself. This is theta. This is factor A. This is factor B. This is theta here. From yes, A to B. Then write B cross A. B cross A is magnitude of B into magnitude of A into sine of the angle between the vectors B and A, angle between the vectors B and A. Here, my friends, what is it? This is between angle between A and B. Here theta is angle between the vectors A and B, but this is sine of the angle between the vectors B and A into eta cap. Yes, my friend. What is this? Magnitudes are such they are scalar quantities. Magnitude of A into magnitude of B into what is the angle? B and A means, my friends, this direction comes here. When it comes this direction, this theta becomes minus theta. Direction is changed. What is theta? From A to B, from B to A, the same theta with a sign change into eta cap. But what is sign of minus theta is minus sine theta. Magnitude of A into magnitude of B into minus sine theta into eta cap, which is minus, this minus, my friend, it is magnitude of A into magnitude of B into sine theta into eta cap, sine theta into eta cap, this, my friends. But what is this by 1? If we name this as 1, this is nothing but minus A cross B, because by 1, therefore B cross A equal to minus A cross B. See, B cross A is minus A cross B. My friends, I'll explain this once again. See, we want to prove vector product is non-commutative. Non-commutative means what? B cross A is not equal to A cross B. By definition, A cross B is this. Plays a very important role. Theta. Theta is the angle between the vectors A and B. Figure. Now B cross A. Now B cross A. Magnitude of the first into magnitude of the second into sine of the angle between first and second. B and A into eta cap. Theta is A and B. B and A means minus theta reverse. This is anti-clockwise is positive, clockwise is negative, minus. Sine of minus theta is minus sine theta. Simplify. This is nothing but by 1. By 1 is A cross B. Therefore, B cross A is minus A cross B. This tells B cross A is not equal to A cross B. Therefore, cross product is non-commutative. Cross product is non-commutative. Non-commutative. Yes, my friends, non-commutative. Next property. Next property. Yes, like this map. In case of scalars, A dot A is magnitude of A the whole square. A dot A is magnitude of A the whole square. In this case, what is A cross A? Second property or third property? Third property. Yes. Then third property. By definition, by definition, A cross B equal to A cross B is magnitude of A into magnitude of B into sine theta into eta cap into eta cap. Yes, my friends, in this, when vector B equal to vector A, then angle between them is 0. This angle, my friends, when what? This is A and B. This is eta cap. This is theta. This is theta. Yes, my friend. When theta is 0 or when B equal to A means what? This theta becomes 0. Implies sine either 0, otherwise another is what? They may be straight angles or pi. Therefore, sine theta is either sine 0 or sine pi. But in both the cases, what? Sine 0 is 0, sine pi is 0. Therefore, putting sine theta equal to 0. Therefore, putting sine theta equal to 0. A cross A pi. B is A equal to. It is magnitude of A into magnitude of B into 0. 0 into eta cap. This entire thing becomes, my friend, not 0 but 0 factor. 0 factor. Therefore, A cross A is 0 factor. But what about A dot A? See there. A dot A is a scalar quantity which is magnitude of A the whole square. Yes, my friends. Ijk, this gives for what? Ijk equal to this implies. It is I dot no. This is I cross I is 0 vector. J cross J 0 vector. K cross K is 0 vector. Yes, my friends, these are your unit vectors here. These are your unit vectors. Origin. This is X. Y axis. What is this, my friend? Z axis. This is unit vector I. This is unit vector J. This is unit vector K. Yes, zeros. And what about another one if they are different? If it is I cross J. I cross J, this my friend. I cross J. It is magnitude of the first vector into magnitude of the second vector into sine of the angle between I and J. These are three mutually perpendicular lines, my friends. Three mutually perpendicular lines means what is the angle between them? Is 90 degrees. Sine 90. Then unit vector perpendicular to both vectors I and J is K into K. What is this, my friend? 1. Sine 90 is 1 into K. Therefore, my friends, I cross J is K. I cross J is K. I hope understood. This figure itself tells what is the angle between the vectors I and J is 90 degrees. And K is a unit vector perpendicular to both vectors I and J. Both vectors, K is the unit vector perpendicular to both vectors I and J. So, in this case, your eta cap is K, unit vector K, in the direction perpendicular to this one. So, magnitude of I is 1, J is 1, Sine 90 is 1 into k. Therefore, I cross j is k. Similarly, j cross k is I and k cross I is remaining factor, my friends. See, same to same is 0 if they are different. If it is I and j, I cross j is what? K. Similarly, j cross k, k cross I. Instead of this, if you take yes, friend, note. We know I cross j is k. Then tell my friend, what about j cross I? What is j cross I? You have to make use commutative property. What is it? B cross A is minus A cross B. B cross A is minus A cross B. But these vectors are taken in order. I cross j remaining, j cross k remaining, k cross I remaining. See, I, j, k, I cross j, j cross k, k cross I. Cyclic order. They are in the order. If they are in the order, it is plus k, plus I, plus j. If it is not in the order, my friends, j cross A is same as minus I cross j, which is minus k. J cross I is minus I cross j, which is minus k. So, I cross j is k, whereas j cross I is minus k. Yes, my friend. Similarly, I take what? I cross k. But what is I cross k? Minus k cross I, pi. It is in the order, therefore this is minus j, my friends. Remember, this is the third property connected with A cross A is a zero factor. If they are different, the remaining factor, unit factor, different, order plus k, they are not in the order, minus the remaining. Remember, my friends. So, the last property on this is, this is fourth property. Fourth property. Yes, if factor A is parallel to factor B, then, yes, my friends, this is factor A and this is factor B. Then what about your theta? Is either 0 or pi. 0 or pi. Then what about sine theta? Sine theta is 0. Yes. Sine theta is sine 0 or sine pi. In both cases it is 0. Therefore, A cross B equal to it is magnitude of A into magnitude of B into what is this, either sine 0 or sine pi into eta cap, but sine 0 is 0. So my friends, this is 0 factor. Therefore, A parallel to B implies A cross B is 0 factor. A cross B is 0 factor. Conversely, my friend, A cross B equal to 0 factor implies vector A is parallel to B, but A dot B equal to 0 implies vector A is perpendicular to vector B. My friend, cross product 0 parallel, dot product 0 perpendicular. Remember, parallel cross 0 perpendicular dot 0. These are properties of vector or cross product. Vector or cross product. What is the first property? Scalar product, vector product is a vector quantity. Vector product is non-commutative. B cross A is not equal to A cross B, but B cross A is minus A cross B. A cross A, 0 vector. Therefore, I cross I, J cross J, K cross K, 0. But I cross J, the remaining, K. If you change the order, you have to change the sign. The fourth one, parallel, cross is 0, vectors are parallel. These are 4 properties connected with cross product. Yes, my friends. The rest we will see in the next class, next video. Yes, my friends. Thank you very much. Please prepare nicely. Vectors is a very easy chapter. Prepare them. Yes, my friends. Yes. Thank you. Namaste. Namaskara. Namaskar. Yes, my friends. Namaste.